Hey everybody, how's it going? I hope that you all had an awesome spring break. Um, so for today, we're just going to do a review of everything that we've talked about so far in this chemistry unit. So let's take a look. So the first thing we talked about was the history of the atom. We didn't talk about it very much. It was sort of, there was that assignment about doing some research about it. Um, but yeah, so it started with the ancient Greeks, who said that all things are made up of these really tiny little particles that can't be broken down any further. They called it atomos. That's where we got the word atom from, but it means that it's indivisible. So basically, they said, like, basically, if you had a piece of cheese and you keep cutting it smaller and smaller and smaller, eventually you would have these super tiny little pieces of cheese that you couldn't cut anymore. As we found out, that's not exactly the case, but they weren't too far off, I guess. They also said that there are 4 elements that make up everything. So there's water, earth, air, and fire. We know that there are 118 elements, and none of these are elements in the periodic table. But yeah, that's what they thought back in the day. Then there's this thing called alchemy. It was a quest for eternal life. And they were the ones, they started basically doing experiments, the people that were doing alchemy, instead of just philosophizing, you could say, like the Greeks did. Then there was this guy, Antoine Lavoisier. He was the first person to standardize chemistry. He also discovered oxygen and determined that water was made up of 2 hydrogen atoms and an oxygen atom, which we call H2O. Then there was this guy, John Dalton, who created his own theory of what an atom is. So he said that it was solid, indivisible, and spherical. So if you imagine like a billiard ball, if you've ever played pool, basically like that, but so much smaller. Then there was this guy, J.J. Thomson. He was the one that discovered the electron, and he said that the atom was a sphere of positive charges with negative charges scattered throughout it. So his model was called the plum pudding model, but you can also think of it like, say, a blueberry muffin, how it's like this solid mass with these blueberries in it, and those blueberries represent the electrons. Then there was a guy, Ernest Rutherford, who did an experiment with some gold foil, and his discovery was that the positive charge was in the middle of the atom, and that the electrons move around this positive center. So you can see in the diagram here, there's the positive center with all of these electrons scattered around it. And then this guy Bohr was also doing research, and he said that electrons were attracted to the protons and the neutrons in the nucleus of the atom, and the electrons are found in these shells that are around the nucleus. So here we can see that these circles represent the shells, these dots represent the electrons, and in the middle we have this nucleus with the protons and the neutrons. And now the theory that we have today, the most modern theory, is that it's called the quantum model, and electrons float in orbital clouds, which might or might not contain electrons. So this is, like it says, the theory that we're sort of working with today, but we're also going to be working with the Bohr model over the next few days and weeks. Next, we talked about the structure of the atom. So we started with the middle, which is called the nucleus, and we said that that is where the protons and the neutrons are. And then on the outside, there are these negative things that go around it called electrons. So starting with the protons, protons are positive, P for proton, P for positive. It has a relative mass of 1. It determines the atomic number, and it's found inside the nucleus. So every element has a different number of protons. If they had the same, it would be the same element. So then there's the neutrons. They're also in the nucleus. They have a neutral charge, or a charge of 0. It also has a relative mass of 1, and it determines the isotope of the atom, of the element. So isotopes, they're just two of the same element with different masses. So for example, hydrogen has 1 proton. It can have 0 neutrons, or it could have 1 neutron. I believe it can also have 2 neutrons. But it's still hydrogen. It just has a different weight to it. And you can do that with a bunch of different elements. Then you have electrons, which are on the outside of the nucleus. Electrons are negative. They're so light that we say they have a relative mass of 0, so they don't factor into the atomic mass at all. And then electrons determine which ion the element will be or will have. So we call positive ions cations and negative ions anions. We are going to be looking at that more in a little bit. So here's just a nice chart summarizing everything. Like we said, protons and neutrons are inside. They each have a relative mass of 1. Protons positive, neutrons neutral. And then electrons are outside the nucleus. They don't really have a mass, and they have a negative charge. Now here we have, next we looked at the periodic table. So here is the periodic table. You can see that it's color-coded with different groups. You can also notice that a lot of the columns are colored the same because they have similar properties, which we are going to talk about in a bit. But yeah, so here we can see that the elements are arranged by increasing atomic number. So we start at the top left with 1, 2, 3, 4, 5, 6, 7, 8, so on and so on and so on. It reads from left to right, just like you were reading a book. There are 7 rows, and those are called periods. And then there are 18 columns, and those are called groups. Also, don't forget that these 2 at the bottom here, they aren't considered extra rows. They actually fit into row 6 and row 7 here. Now, if we look at this square here, we can determine some information about the element. So in the top corner here, that's the atomic number. Then here in the middle, there is the symbol. The symbol is always either a capital letter or a capital letter followed by a small letter. Then underneath we have the atomic mass. The atomic mass is always going to be a decimal number, but whenever we're going to be using it to figure out the number of neutrons and protons, it's always going to be a whole number, so you don't have to worry about that. It's just a decimal because it factors in the different isotopes or the different alternate forms of the element. And then at the bottom, it is the number of valence electrons, which will also be very important. So the atomic number refers to how many protons an atom of that element has. No 2 elements have the same number of protons, and if they did, they would be the same atom. So just like I said earlier with hydrogen. The atomic mass refers to the weight of the atom, and the way that we do that, or the way that we find it, is we add the number of protons to the number of neutrons. Now if we look at the periodic table, all of these ones here in blue, those are all metals. Then there is this like staircase sort of down the middle. Those are called metalloids. And then these green ones here and here at the top left are nonmetals. You can see that the metals are all on the left side of the periodic table and the nonmetals are all on the right side. And you can also see that there are way more metals than nonmetals in the table of elements. So at the top left, that's where hydrogen is. We put it there in group 1, like with all the metals, not because it is a metal, but because it has 1 valence electron. So that is common for all of the elements in that first group. And it says here that it has 1 proton and 1 electron in its only orbit. We're going to be looking at orbits later this week. Now the rest of that column, those are called the alkali metals. They also have a single electron in their outermost orbit. or you could say they have one valence electron. They are shiny, they have the consistency of clay, and you can easily cut them with a knife. They're also the most reactive metals. They react violently with water, and they're never found on their own as free elements. The second column they're called the alkaline earth metals. They're in column 2. They have 2 valence electrons. So column 1 has 1, column 2 has 2. And some of the elements in there are magnesium, calcium, there's also beryllium, and a few others. All of these elements in the middle, they are called the transition metals, and they're the ones like you've heard of, like copper, tin, zinc, iron, nickel, gold, silver, so on and so on. They're also good conductors of heat and electricity. They're used a lot with batteries as well. Now this group here, this is group 17 called the halogen family. They have 7 valence electrons. So 17, 7, that's a good way to remember it. They're the most reactive when it comes to nonmetals, and they react very well with column 1 here, the alkali metals. So these ones, they want to lose their one and only electron, and these ones want to gain 1 electron so that they have a full outer shell, and then they're both stable together. And then the last column, those are the noble gases. They are also called inert because they don't react at all. They already have a full outer shell, so they don't want any more electrons in their shell. They don't need to lose or gain any. They're already stable. So some of the elements in there, there's helium, neon, argon, krypton, xenon, and radon, and they are all found in small amounts in the Earth's atmosphere. So that's everything that we've talked about so far. Later on this week, we're going to be taking a closer look at the Bohr model, and we're going to be drawing the Bohr models and trying to understand how the electrons are placed outside of the shell for the first 18 elements in the periodic table. So I hope you found this informative and useful. I hope that you all had a good spring break, and I'll talk to you guys later. Bye.